Alright, we're going to do some more integration. Today we're going to start with a problem like this. It says find the area region of the region bounded by the graphs and these equations. So I'm going to go ahead and write this integral, and the integral is saying from 1 to 5. And it's telling me that it's bounded by the x-axis of the function x plus 6 over x dx. So what I'll go ahead and do is just integrate this. I'll rewrite it. X divided by x is 1. And then I have 6 over x dx. So I end up getting x plus 6 ln of absolute value of x. And I'll plug in my 1 and my 5. So when I plug in my 5, I get 5 plus 6 ln of 5 minus, plug in 1, 1 plus 6 ln of 1. And then I can simplify this to be 5 plus 6 ln of 5. This would be minus 1. And then this would actually be plus 0 because the ln of 1 is 0. So final answer, 4 plus 6 ln of 5. In my next example, they're asking me to find the average value of the function. If you remember, average value that is talking about was its average height. So I need to do 1 over 4 minus 2, 1 over b minus a. And the integral from 2 to 4 of my function, I'll say it's 4x plus 4 all over x squared dx. I'm going to go ahead and change my mind here on distributing that, because what I could do on my next step is actually factor out or bring out this 4, not factor it out. So I'll bring out my constant. So I've got 4 over 4 minus 2, 2 to 4 of x plus 1 over x squared. That allows me to rewrite this again. So that's 2. When I have 2 to 4, x divided by x squared would be 1 over x plus, this would be 1 over x squared dx. Ready to integrate this, I get 2. This would be the ln of absolute value of x plus the integral of this is actually x to the negative 2. So I'd raise it by 1, put it over that power. I don't need a plus c because I'm doing it from 2 to 4. I'll come up here to finish this. So I've got 2 ln of x plus, this is really negative 2, and then this is on the bottom of the fraction from 2 to 4. So I end up getting 2 ln of 4 minus, plug in 4. That would be 1/2 once you reduce it. Plug in 2 minus 2 ln 2 minus 2 over 2. So I have 2 ln 4 minus 1/2 minus 2 ln 2 minus 1. You can punch that on the calculator and get an answer, or we can just leave it in this form. We could also say this is the ln of 16 if you want to bring this up front and make it squared. Negative 1/2 and a negative 1 gives me a negative 3/2. And then I could also say this is the ln of 4. The best I can do is make that a decimal if you wanted to. I have one more problem, but I'll do that in the next video. Okay, for this particular problem, I'm given a differential equation. What I want to do is I'm going to write an equation that gives the population at any time t, and then I'm going to find that population after 3 days. So I'm going to go ahead and solve for dp first. So that means I'm going to multiply by dt on both sides. So I've got 3,000 over 1 plus 0.25t dt. So now I'll integrate both sides. The integral of dp is p. I can bring out this 3,000. And now I can see that I'm going to want to make a u statement with the bottom. And when I take the derivative, I end up with 0.25 dt. Well, I only really want the dt, so I'm going to move this to the other side. But I'm going to go ahead and erase this 0.25 and make it a fraction of 1/4. So that way I know that this is really just 4 du. So my new population ends up being 3,000. Bring that down. I have the integral of 1 over u. And I just wanted the dt part, so I need a du and a 4. So that makes my population be 12,000. The integral of 1 over u is ln of absolute value of u plus c. It does give me my initial population of 1,000. So I am going to go ahead and finish rewriting this by putting in what u was equal to, 1 plus 0.25t plus 1,000. The last step in this is to go ahead and plug in and see what p of 3 is. So you would plug in 3 for your t right here, and if you use your calculator and you enter it in properly, you should get about 7,715.